Hello, this is Fractions Number Theory Study Guide number 4. Quite a few things on it, so please watch this with your child, and I think hopefully it will help them as we go through these mini skills. All right, just to show you what you're going to be doing on this one, you're going to learn to write a decimal as a fraction, write a fraction as a decimal, convert a mixed number to an improper fraction, convert an improper fraction to a mixed number, compare and order fractions, decimals, mixed numbers, and improper fractions, add and subtract like fractions, and add and subtract unlike fractions. And I'm going to get a clear screen here, and I'll go through all of these fairly quickly. Once again, if you have any questions or concerns, you can always email me or call me. Feel free to do that. But I will go through each one of these. Hopefully it will be sufficient to help you and your child better understand what we're going to be doing over the next couple of weeks. Alright, I'm going to get a clear screen here and we will get started. Alright, hopefully you will keep that study guide beside you while we go over these. Alright, to change a decimal to a fraction. I'm going to give you a couple of decimals here. One example that I use is this one. And this is what your directions say. It says say it to yourself and then write down what you have said. You can't just say 0.18. You've got to say it with its value. So this would be said 1800ths. Alright, so 1800ths. You have to say it like that to get the full meaning of what you're doing. Alright, so that's in word form, but if I were to write this as a fraction, I'll write it like this, 1800ths. Alright, so I've looked at it, I've said it to myself, I've written down what I've said. Now the last step, and in most cases this is what is required of any of the students, you have to simplify it. And this, as I told you in the last study guide, everything you'll be doing in fractions, they'll pretty much say we want it in simplest form, so that's pretty much a requirement. What you want to do is find a number that will divide into 18 and also into 100. This is where divisibility rules come into play and also multiplication facts. The most obvious number that will go into both of them is 2. I'm going to divide by 2. 18 divided by 2 is 9. 100 divided by 2 is 50. Then I'll look at it again. Is there any other number that they have in common as a factor? Is there any other number that will go into 9 and 50? There's not. So this is what 1800ths as a decimal is as a fraction in simplest form. Okay? You can do all of these like that. All you do is take your decimal, say it to yourself, write down what you say. It says 2500ths. Then simplify if possible. Find a common factor, a number that will go into both of them, preferably the greatest common factor. That'll be 25. 25 into 25 goes once. 25 into 100 goes 4 times. So 2500ths is 1/4 in fraction form. All right, let me do one more real quick. All right, let's do a mixed number, or let's do 2.38. All right, if you notice how I said that, I said 2.38, and that's not going to help me a whole lot if I want to convert that to its fractional form. All right, a mixed number, let me just go and go over that because you're going to see that in a minute. A mixed number is a combination of whole numbers and parts of numbers. All right, but I'm going to say this, then I'm going to write down what I say. 2 and 3800ths. Remember, you have to know your place values. First place is the tenths, hundredths, thousandths, 10,000ths, and so on. All right, I've said 2 and 3800ths to myself. Now what I need to do is simplify this if possible. Once again, I'm going to divide by 2 because they're both even numbers. All right, 38 divided by 2 is 19. 100 divided by 2 is 50. So 2 and 3800ths in decimal form is 2 and 1950ths in fraction form, or as a mixed number. Okay, next section, to change a fraction to a decimal. All right, you can do this a couple of ways. I'm going to do a real simple one at first. Here's a fraction, and I'm asked to change that to a decimal. Now, there's a special note at the bottom of this first page that says if the students can memorize as many of these as they can, and we know them ourselves, most of us. Just going to put a couple up here. These are unit fractions because they have number 1 in them. Anytime you see a 1, those are called unit fractions. All right, I'm going to put these in their decimal form, and then we'll talk about it a little bit and how I found it. Okay, I've converted those fractions to their decimal equivalent. So how did I do it? There's a couple of ways to do these. All right, you've seen these examples here, and I'm going to get rid of them and then go back and do them again. All right, this says 1/2. First of all, hopefully the students know that that is 0.5 as a decimal, but if they don't, there's a couple of quick ways to find out this decimal equivalent. Now here's one of them. If the denominator naturally goes into a number that is a multiple of 10, remember our decimal system is based on the number 10. Every place value is 10 times bigger or 10 times smaller than the one beside it. It all depends on which way you're going. So if I had 2.15, this 1 is smaller than this one based on its position in the number, based on its position relating to the decimal. All right, so one thing I can do is I look at my denominator and say, hey, does this number go into a number that's a multiple of 10? Well, it goes into 10. All right, now I can use my rules about finding an equivalent fraction. 2 will go into 10 5 times. So whatever I do here, I can do, if I do the same thing up here, I'll find an equivalent fraction. All right, there's 5/10. Okay, now I can use the rule that I used previously. I'm going to change this to its decimal equivalent by just saying it to myself and writing that. This says 5/10, and that says 5/10. All right, let me do another one. All right, 1/5. Will 5 go into a multiple of 10? Yes, it'll go into 10. 5 times 2, 1 times 2. So 1/5 is the same thing as 2/10. Say 2/10 to yourself, write it as a decimal. 2/10 says 2/10. All right. Now let me put 1/4 up there. And you've got a little problem here. 4 won't go into 10, but 4 will go into 100. And 100 is a multiple of 10, so I can go from 4 to 100 by multiplying by 25. Then 1 times 25 is 25. Say that, 25 hundredths, write it as a decimal, 25 hundredths. All right, let me put the last one I had up here, 1/3. All right, let me see if I can do that with 1/3. 3 won't go into 10 evenly as a whole number. Won't go into 100. Won't go into 1,000. Won't go into 10,000. So what do I do? Well, the other method to change a fraction to a decimal is to divide the numerator by the denominator. In other words, divide the bottom number into the top. So I'm going to do that. And the first thing you'll notice is you say, well, look, you can't divide that. But in math, you can do pretty much anything you want to if you follow certain rules. And I do have a rule to allow me to divide a bigger number into a small number. The rule says to put a decimal where it goes in the number. Since 1 is a whole number, the decimal comes after it. Bring that decimal point up, okay? Bring it up, and you're done with it. Then add zeros. All right, now I can divide. Ignore your decimal. This decimal's not there now. Don't even worry about it. 2 goes into 10 5 times. 5 times 2 is 10. So there's the other method that you can do. You can always divide the denominator into the numerator, and you can get that equivalent. Now, so I'll do the one I did previous with 1/4. Remember, I've changed it to a number over 10, 100, 1,000, or whatever. But this time I'm going to divide 4 into 1. Put my decimal point, bring it straight up. Now add zeros. 4 goes into 10 2 times. Well, this time it didn't end up evenly. So what do? I subtract, add another 0, and I bring down. 4 goes into 20 5 times. 5 times 4 is 20, so there's my decimal equivalent. Okay, now let's look at the one I just did, 1/3. All right, we've already decided I can't divide 3 into a multiple of 10. I can't divide into 10, 100, 1,000, 10,000, so on, so on. All right, so what do? Well, I'm going to divide 3 into 1. I'm going to do the same thing I did previously. I'm going to add a decimal. I'm going to bring it up, and I'm going to add zeros. 3 goes into 10. Let me change that color. 3 goes into 10 3 times. 3 times 3 is 9. Subtract. 10 minus 9 is 1. Add a 0, bring down. 3 goes into 10 3 times. Now, by about this time, you should notice something. This is never going to end. I can do this forever, for the rest of my life, and I'll never get finished. If someone told me that's your job the rest of your life, well, this would keep me busy the rest of my life. So what do? Well, there's a way to indicate that it never ends, and I showed you that previously. One way is just put a bar over what repeats. The 3 repeats, it's going to go on forever, so that bar indicates that it does go on forever. Another way is to write down the numbers that repeat. In this case, this is single digit. It's a good idea to write it down at least twice, just so you'll know that the 3 is what goes on forever. Then put that indicator, and that says, hey, it goes on forever. All right, let me do a couple more here, because some of them do get a little more difficult. One example that I use is 5/8. All right, 5/8. 8 won't go into 10 by a whole number. 100 will go into 1,000. Now, a lot of students won't know this, but I'm going to show you that it does work. 8 times 125 is 1,000. So if I multiply 5 times 125, I'm going to get 625. So, say that to yourself. That says 625 thousandths. So you write down 625 thousandths. So that was pretty simple. Now, since a lot of students don't know that 8 will go into 1,000, it might be quicker just to go ahead and divide the bottom into the top. It works every time. All right, I'm going to add my decimal again. I'll bring it up. Now, this one's going to take a couple of divisions to get to where I want to be. 8 will go into 50 6 times. And I'll put this down too far on my paper, but we'll make it work. 8 will go into 20 5 times. Sorry, 2 times. I'm already ahead of myself. I do that a lot. I get ahead of myself sometimes. I get a 4, bring down another 0. 8 will go into 40 5 times, and I am done. All right, so you can see I got the same thing. All right, so you can do it a couple of ways. If the number naturally goes into a multiple of 10, 100, 1,000, any value that we use in our decimal system, you can do it like that, or you can always divide the bottom number into the top, the denominator into your numerator, add a decimal, bring it up, and start dividing. Okay, very good. All right. To convert a mixed number to an improper fraction. Now, this is going to be required when the students start dealing with adding and subtracting, and some multiplying and dividing of fractions and mixed numbers. Now, let me just make this clear here. In 5th grade, students have to be able to add and subtract like and unlike fractions. So like fraction are fractions that have the same denominator. Unlike fractions, the denominators are different. So that's where they're having to use some of the other skills that we'll be talking a little bit more in just a few minutes. All right, but the skill says to change a mixed number to an improper fraction. All right, I'm going to write 3 1/3. Okay, how do I change that to its value as an improper fraction? Now, what is an improper fraction? An improper fraction is a fraction where the numerator is bigger than the denominator. A proper fraction is a fraction where the numerator is smaller than the denominator. All right, so if you notice here, I've got 1 out of 2. Here I've got 10 out of 3. Well, that means there's some whole numbers stuck into this one. So we're going to find out how to convert from one form to another, then back. And then I'll show you where it's used. All right, this is what your rule says. Your rule says to take your denominator, multiply it by your whole number, and then add your numerator. So I'm going to do that, and then I'll break it down a little bit slower. 3 times 3 is 9. 9 plus 1 is 10. Then your denominator stays the same. Now, how did that work and why did it work? Well, first of all it's saying is when I multiply this 3 times this whole number 3, I'm trying to find out how many thirds there are in 3 wholes. Well, I know there's 3 thirds in one whole. There's 3 more thirds in another whole. There's 3 more thirds in another whole. So I've got a total of 9 thirds. That makes sense. So I can just do that. I can say, well, look, I've got 3 thirds, 3 thirds, 3 thirds. But it's quicker just to multiply your denominator times your whole number. That tells you how many thirds there are in 3 wholes. Then add however many more thirds you have. I've got 1 more third here, so I have a total of 10 thirds. All right, let me do one more of those. One example I use is 3 3/4 in your study guide. All right, I'm going to multiply denominator times whole number. That will tell me how many fourths I have in 3 wholes. Well, I've got 12 fourths. Since there's 4 fourths in each whole, and I've got 3 wholes, I've got 4 fourths plus 4 fourths plus 4 fourths, which is 12 fourths. All right, so that was the 4 times 3. Then add the 3 more fourths that you have right here. So you've got 12 fourths plus 3 fourths, and that gives you 15 fourths. Okay, pretty simple. Now, there's going to be times when the students have to convert back. They have to go back from an improper back to a mixed. Well, this rule is pretty simple as well. All they have to do to convert back is to divide the denominator into your numerator. Just like we did when we were converting from a fraction to a decimal, I can do this too, but I'm going to leave my answer as a mixed number. 4 goes into 15. Now, I'm not going to worry about a decimal. I'm going to leave it as a fractional equivalent here. 4 goes into 15 3 times. Now, I get a remainder, and I don't do what I did before. I don't add a decimal. I just take my remainder, and I put it over what I divided by. Put it over my divisor. So 3 and 3/4. Now, if you remember, that's what I started with a minute ago when I went the other direction. When I went from a mixed number to an improper, well, look what I did here. I went from an improper back to a mixed. So let me do another one of those. All right, I've got 63 over 8. I want to see what that is as a mixed number. All you're doing here, how many whole groups of 8 do you have in 63? That's all they're asking. So I divide my denominator into my numerator. See, and I've said this all year, and I'll keep saying it. I've still got some students that cannot use their times facts, and if you've noticed lately, everything that we've done, if you don't know them, they're gonna get bogged down, and that's what's happened with some of them. Please keep practicing these times facts. If you don't, it's not going to be a good situation for your child, because they're going to get further and further behind. These are 5th grade requirements, and a student in 5th grade must know their times facts. It's impossible to do well without it. All right, 8 will go into 63. I should know that immediately 7 times. 7 times 8 is 56. Now I'm going to subtract. I get 7. What do I do with my 7? I take it and I put it as my remainder. I don't just say remainder of 7. I take my 7 and put it over the 8 that I divided by. So there's 7 and 7/8. So 63/8 as a mixed number is 7 and 7/8. Now let me just go in reverse, and I'll just show you that this is just a review of what we just did. What if I wanted to go backwards? Remember, denominator times whole number. That tells me how many eighths I have in 7 wholes. Well, I've got 56 eighths in 7 wholes. 8 times 7 is 56. Plus the 7 more eighths, and there's my 63/8 again. So I went from one form back to another. All right, now to compare, What if you had a problem like this? 1/2 and 0.48 or 48 hundredths, and the student was asked to place greater than, less than, or equal to between those. Well, let me show you one thing I've shown the students to do first of all. I've still got a few students, even after learning these signs, that cannot keep them straight, and I've shown them what to do, and I'll talk about this in just a minute. This is another thing that you have to have memorized. You cannot survive 5th grade, especially middle school, unless you can keep those signs straight. Greater than, less than, but I'll show you a little trick I've shown them. Some use it, some don't. Okay, all right, now first of all, you can't compare different things. I've got 1/2 and I've got 48 hundredths. Well, they're not the same. One is a fraction, one is a decimal, so I've got a couple of options here. I can change my fraction to its decimal equivalent, or I can change my decimal to a fraction. And then I can compare them. Well, the problem is, I got to decide which one is better for me. Now, I know what I would do in this one. I already know that 1/2 is 0.5. So, I didn't have to do any work. My rule says the first place that you come to that's bigger, that's the bigger decimal. Well, the 5 in the 10th place is bigger than the 4 in the 10th place. So this one's automatically bigger. So I knew that. Well, if I don't know that 1/2 is 5/10, I need to either do what I did before. I need to change this one to a decimal by writing it as a number over 10, 100, 1,000, 10,000, whatever. Or I need to divide the bottom into the top. Well, if I didn't want to do that, I'm going to have to take 0.48 and write it as a fraction. So it will be like 1/2. Well, I'm going to do that. I'm going to write it 48 hundredths is written 48 hundredths. Then I'm going to simplify it. And 4 will go into 48. I'm going to divide by 4. I'm using the greatest common factor. And it's going to go, and I need to change my color. I'm getting on my margin again. Alright, let me find what I got here. There we go. Alright, this will be 48 divided by 12 is 4. I still can't see it, sorry. There. 4. 100 divided by 12, well, it won't go. Alright, so what do I have to do? That number's not right. And a lot of times the students, what they'll do, when they're simplifying, they'll just pick a number that will go into either one of them and not both of them. Remember, when you're dividing, you've got to find a common factor. It can't be just any number. It's got to be a number that will work into both of them. Well, what will go into 48 and 100? Well, how about 4? 12 was a little bit too ambitious, and that's what the students are doing. They don't think, well, this needs to be a number that will go into both of them. That's why they're called common factors. All right, let me make that a little clearer. All right, I'm going to divide by 4. And I'm going to get 12 25ths. So now what I've done, I've changed 48 hundredths to its fractional equivalent, which is 12 25ths. Now I can compare it with that. And you say, well, how are you going to do that? Well, the students have been taught that they can do what's called a cross product. Multiply those two numbers together and they get 25. You put it right up here beside this numerator. This is 25 times 1, 25. 2 times 12, 24. All right, now you put that one beside this numerator. All right, if 25 is greater than 24, if the product is greater, the fraction's greater. And that's a rule that the students have taught, and it's been in previous study guides. All right, now that's a lot of stuff. Let me put another one up here, and we'll do another one like this. How about 3/4 and 0.7? All right, what if I want to compare those? All right, I'm going to do one of two things. Well, first of all, if the students have this memorized, they know that this is 0.75. 3/4 of a dollar is 75 cents. Well, this is pretty easy to compare. This is bigger because if I added another value here to make them balanced where I'd have two numbers in each decimal equivalent, this would be a 0. All right, so my rule says the first place that you come to that's bigger, well, the 7 and the 10th and 7 and 10ths are the same, but the 5 and the hundredths is bigger than a 0. So that is greater. Now let me show you the little trick I've shown the students. I've told them if you have trouble keeping these signs straight, they've got to get them memorized, but if they're still having trouble, put 2 dots beside the number that's biggest. Then put 1 dot beside the number that's smallest. 75 hundredths is bigger than 7 tenths. 2 dots go here. Then connect them, and you'll always have your sign right. All right, so let's go back and actually work this one though. All right, I want to change this to a decimal, so I'm going to change it to a number over 100 because 4 goes into 100. 4 times 25, whatever I do here, there's 75 hundredths. All right, then I can say, well, there it is. Or I could divide 4 into 3, put a decimal, bring it up, and start dividing. 4 goes into 30 7 times, subtract, bring down another 0, 4 goes into 25 times, 5 times 4 times, so I'm done. Now, it may be easier on this one. See, this is what I've seen a minute ago. It might be easier for the students to understand, hey, which would be the easiest thing for me to do? Well, the easiest thing for them to do is have these fractions like 3/4 memorized. But let's say they don't. Well, I may find that this number is easier to convert to a fraction by just saying it to myself. 7 tenths is 7 tenths. Well, that is pretty easy. Now I can do 10 times 3 is 30. I can do a cross product. 4 times 7 is 28. 30 is bigger than 28, so 3/4 is bigger than 7 tenths. All right, now, there's other ways to do these comparisons. You can, let's just say if you had, let's do, I don't want to make it too hard, let's do 2/3 and 0.62. Well, if I know that 1/3 is 0.3 with a bar over it, which means 3's will never end, 2/3 is going to be 0.6 that will never end. And if you'll notice that that's at the bottom, that's one of those equivalents that would be good for them to memorize. But if they don't memorize it, they're going to have to do a couple of things. They're either going to have to divide 3 into 2, and you're going to see that you're going to get 6's forever. It's never going to end. Keep dividing till you know what's going to repeat. Well, I know my 6's are going to repeat. Well, this is what I've got. I've got 0.6's forever, 0.62. Well, 0.6 is forever. That means in the hundredths place here, I would have another 6. So that's bigger, okay? Now, once again, the students will learn that sometimes it's easier to do one conversion one time and one another. If I had 19 over 48 and 0.4, let's say, they're going to find out, hey, you know what, I don't think I want to divide that into that, because that's going to be a division. They may want to change this to 4/10 and then use another rule. So it all depends on the situation, and I can't show you every possible situation here. But this way, then I can do a cross product. 10 times that's 190. That was pretty simple. And then 4 times 48 is going to be almost 200. 4 times 8 is 2. So that's 192. Look how close they were. So you're going to have other strategies to use sometimes. 190 is less than that, so that's less than that. But it's barely. So some of these can be tricky. All right. Just read through these, and there's quite a few examples to show you. Now, if you had, let's say if you had a problem like this, 3/4, 0.45, 7/8, and 0.6. All right. What if you're asked to put those in order from least to greatest or greatest to least? Well, you're going to have to do the same thing. You're either going to have to change them all to a decimal or all to a fraction. It all depends on what is easiest for you. Well, I know what's easiest for me here, since I've got a lot of these memorized. I'm going to change them all to a decimal. I've already got a decimal value here. I've got a decimal value here. Now, if they memorize these, they'll never have to work these problems again. That's 75 hundredths. Well, this is 45 hundredths. And if you notice at the bottom of the page, I've got the eighths down there. 7/8 is 0.875, and 6/10 is 6/10. And you can look and say, oh, this is easy. Here's the smallest. That's the next smallest. That's the next one. And that's the next one. So the more they can memorize, the easier it's going to be. All right, now I'm going to go through a little bit of adding and subtracting like and unlike fractions, and I'm going to do this fairly quickly. I'm just going to put a real simple one here, and then we'll get going. I've got 1/4 plus 1/4. All right, now the most common mistake students are going to make is they're going to say, hey, this is easy. I'm going to add 1 plus 1 is 2. And then I'm going to add 4 plus 4 is 8. So 1/4 plus 1/4 is 2/8. Well, that's the most common mistake, and I'm going to show you why that's flawed. If you simplify the sum of these two, you're going to get 1/4 again. Because if you simplified it, if you divide it by 2 to get a common factor, you're going to get a 1/4. So that doesn't make sense. I can't have a quarter, somebody give me another quarter, and I end up with a quarter. Well, here's your rule. The rule's very clear. The rule says to add fractions with the same denominator, like denominators. Add your numerators. 1 plus 1 is 2. And your denominator stays the same. Now, let's see if this makes sense. I've got a quarter. Someone gives me another quarter. I have 2 quarters, which is a $1/2. So it makes all the sense in the world. So you have to caution your child. Your rule is, you have to follow your rules. Add your numerators, your denominator stays the same. So 1/4 plus 1/4 is 2/4. Simplify it always, and you got your answer. Now, that's pretty simple. Now, you're going to run across problems like this sometimes. Let's say if you add 7/10 plus 9/10. Okay, I'm going to use my rule. My rule says to add my numerators. I'm going to get 16/10. 7 plus 9 is 16, and then I have tenths. But that is not a good way to express an answer. You wouldn't say, well, I've got 7/10 of a dollar and 9/10 of another dollar, and I have 16/10. No, that's not very clear. So what you have to do here is use one of the other skills that we had on the study guide. You have to convert this improper fraction to a mixed number. Well, how do you do that? You can divide 10 into 16, one whole time, take your remainder, put it over your divisor, and then simplify. 1 6/10, you can divide by 2 here. You can divide by 2 here, so your answer is 1 3/5. So I have 1 3/5 dollars, which is $1.60. You can also simplify right here. You could say, well, look, I think I'll simplify it before I change it back to a mixed number. I can divide by 2. I can divide by 2. Dividing by 2 there, dividing by 2 there, I'm going to get 8/5. Then you can divide 5 into 8, one whole time with 3 left over. So you get all kind of options there. All right, so adding and subtracting like fractions is pretty simple. Now this is where it gets a little tricky. Let's do 1/2 plus 5/8. All right, I tell the students you can't add things that are different. You can't subtract things that are different. You have to get them in the same terms, or make them the same before you can do that. Now this is where the students have to know about least common multiple and finding the equivalent fractions. Least common multiple is the smallest number that 2 or more other numbers will go into. Now, basically what this means is this. I've got to change 2 and 8 to the same denominator. Well, how do I do it? One way, and this is in study guide number 2, very detailed. You can list the multiples of 2. Well, These are the multiples of 2. It's like skip counting. 1 times 2 is 2. 2 times 2 is 4. 2 times 3 is 6. 4 times 2 is 8. And it goes on forever. These are multiples. A number I get when I multiply 2 by something else. 2 times 1, 2 times 2. 2 times 3, 2 times 4, 2 times 5, and so on. Well, here's the multiples of 8. What will I get when I multiply 8 by something else? I'll get 8. I'll get 16, I'll get 24, I'll get 32, and it goes on forever. Well, the least common multiple is the smallest number that they have in common as a multiple. Well, if you look at these two lists, I see an 8 here and an 8 here. Well, that's the lowest common multiple. So what I'll do now is I'll change them to 8s. Then I can either add or subtract them. Well, the good thing about this is this one is already in 8s, so 5 eighths equal 5 eighths. Well, how do you change 1/2 to 8ths? I remember our rule to find an equivalent fraction. You find the relationship between either the denominators you know or the numerators. So I know my denominators, both of them. 2 times what is 8? 4. Whatever I do here, I'm going to do the same thing here. 1 times 4 is 4. All right, now I can add them. I've got them in the same terms, in the same denominators. 4 plus 5 is 9. 8 is my denominator, so I've got 9 eighths. Now, I have to use that other skill where I change my improper to a mixed number. Divide the bottom into the top, denominator and numerator. 8 will go into 9 one whole time. Take your remainder, put it over your divisor, and you're done. All right, let me do another one of those, a little harder. Let's do 17 over 24 minus, let's do 2/5. Let's do that. This is a little bit more challenging. All right. I need to find a number that I can divide 24 into 5 into. And this is where it gets a little more difficult. Remember, one way you can do this is to list the multiples of each of your denominators. 24, 2 times 24 is 48. 3 times 24 is 72. 4 times 24 is 96. On and on and on. It never ends. Well, here's the multiples of 5. 5 times 1, 5 times 2, 5 times 3, 5 times 4. Now, if you notice something, I'm going to have a problem here because one of these lists, one number is so much smaller than the other one, it may take me a long time before I find a common multiple. So there's got to be other ways to do this. Well, one way you can always find a common multiple, a number that these two will go into, is just multiply them together. If I want to find a number that both 24 and 5 will go into, I can multiply those together because that makes sense. If 5 goes into 120, I wonder how many times it goes. It goes 24. If 24 goes into 120, I wonder how many times it goes 5. So you can always multiply them together, but that doesn't guarantee that it's the smallest multiple. But in this case, it is, and I'll show you why in just a minute. All right, I know they'll both go into 120. Well, how many times will it go? Well, it's going to go 24 times. How do I know? Because 5 times 24 was 120. So whatever I do here, I do here, and I get 48. How many times will 24 go into 125? 17 times 5 is 85. Now I've got them in 1/20ths. Now what do? Well, I add them up. 85 plus 48 is 133 over 120. What did I do? I just added my 85 and my 48. I got 133. Now, I've got to convert this to a mixed number. How do I do it? I divide 120 into 133. It goes one whole time with 13 left over. So my answer's 1 and 13 1/20. So you can see they can get fairly complex. Okay, let me do another one. I'm going to show you another way to find least common multiple. All right, let's make this 7/8. I'm going to do a subtraction. Minus, let's do 5/6. Okay. Now, I need to find a number that 8 and 6 will go into, because I can't really do anything until they're in the same terms or using the same denominator. So I can write out my multiples: 8, 16, 24, 32, forever. 6 would be 6, 12, 18, 24. All right, now all of a sudden I say, hey, there's a common multiple. They each have 24. So I can change them to 24. And that was pretty quick. All right, now I'm going to change them to 24 by using my rules about finding an equivalent fraction. 6 times 4 is 24. 5 times 4 is 20. 8 times 3 is 24. 7 times 3 is 21. Now look how close those were. Now I knew it was going to be kind of close. Just, I want to show you that if you didn't change them, you're going to have a problem. You've got to get them in the same terms before you can add or subtract. But now 21 minus 20 is 1. 1/24. All right, now that brings up the issue of how to find least common multiple. Let me put that one back up here again. And this is in study guide number 2. And I'll show you a couple of ways to find least common multiple. It doesn't matter to me how the students do it, as long as they can do it quickly, because you can't spend 15 minutes trying to find that. If they can't find a common multiple, they just need to multiply the two together. It's no big deal. They just have to simplify more. So if they can't find a lowest common multiple, multiply them together, and then they've got a number that will work. Now, I'll do that, and I'll show you it's no big deal. I'll just have to simplify more than I did before. 6 times 8 is 48. 5 times 8 is 40. 8 times 6 is 48. 7 times 6 is 42. Now I've got 42 minus 40 is 2 48ths. I've just got to simplify by finding a common factor. 2 divided by 2 is 1. 24 divided by 2 is 24. And I got the same answer. No problem at all. All right, but there's going to be times when you want to multiply them together. All right, I'll give you an example. What if I had 1/3 plus 3/60ths? All right, I can multiply those together and use 180 as my lowest common denominator. I can do that. Another way is I can just think. I've got to find a number that 60 and 3 will both go into. Well, it's got to be at least 60 for 60 to go into. So one thing I can do is think about the big number. Just think about the big number and say, well, look, it's got to be at least 60. So I'm going to think 60. Will 3 go into 60? Yes. So I'm done. I found my lowest common multiple, which is going to be my lowest common denominator. 3 times 20, 1 times 20. Okay, then I can add them, and I got 23 over 60. All right, now let me put one with 3 numbers up here. 3 fractions. Let's say I've got 1/5, because there's going to be times when the students have this. Plus 1/7 plus, let's see, 1/14. All right, I'm going to use that same method here. It's got to be at least as big as 14, or 14 to go into it. So I'm going to think about the multiples of 14. 7 are going to 14, but 5 won't. All right, here's 28. That's 2 times 14. 7 are going to 28, but 5 won't. Well, here's 3 times 14. It's 42. Now, if you notice what you can do, if you have trouble, if you don't know these by heart, you know, I'm a lot older than the students, and I pretty much know most of these by heart anyway. But what you can do is write down the number, and 14 plus 14 is 28. And then after that, you can just add 14 to 28, and there's where your 42 came in. Well, the next one's going to be 14 plus 42, which is 56. Okay, 7 are going to 56, but 5 still won't. Well, now let's add 14 to 56 to get another multiple. Well, that's 70. And all of a sudden you say, wait a minute, 14 will go into 70, 7 will go into 70, and 5 will go into 70. So there's my lowest common multiple. Otherwise, you would end up having to multiply 5 times 7 times 14, which is 35 times 14, you got a huge number. So there's better ways to do it. Now let me show you one other way. And then I'm going to show you another couple of quick things and we'll be done. All right, another way to do this is do factor trees on all your numbers. 5 is just 1 times 5. 7 is just 1 times 7. 14 is 2 times 7. Now this is what your rule says, and this is explained on study guide number 2. Pick the greatest number of each prime that you see in your list. In other words, if I have 5 2's in one list and only 3 in one list, I've got 5 2's, that's my greatest. Well, I have 1 2, that's the greatest number of 2's I have in any of these 3 lists. I've got 1 2, I've got 1 5 here. That's a 7. I'm ahead of myself again. I'm already thinking ahead. There's a 5. And then I've got 1 7 in each list, but the most I have in either list is 1 7. Multiply those together, and there's your 70. All right, so let me demonstrate that with another set of numbers. I want to find the greatest common factor. Let's just make it simple to demonstrate. Let's do 1/10 and 1/15. I want to find a number that 10 and 15 will go into. Well, I can multiply those together. 10 times 15 is 150. But I don't like to use the big numbers because I've got to simplify more. So I'm going to use factor trees. Or I can do this. I can say 15 times 1 is 15. 10 will go into 15. 15 times 2 is 30. Whoa, 10 will go into 30, so I found it. Well, I'm going to do it using factor trees. Here's 10, 2 times 5. That's the prime factorization of 10. Here's 15, 3 times 5. That's the prime factorization of 15. All right, so what is the greatest number of each prime that I see in my list? Well, I see a 2. That's the most 2's I see in either list. I see a 3. That's the most 3's I see in either list. And I see a 5. 5 is in both lists, but the most I see in it together is one of them. 2 times 3 times 5 is 60. 30, sorry. It's 30, and that is your number that you want to use. All right, hopefully that helped. Let me show you a couple of problems that the students are going to run across real quick, and then we're done. Adding and subtracting mixed numbers. All right, the students will be doing quite a few like this, so just be prepared if they have questions. All right, what if you've got 8 minus 3 3/4? All right, I'm going to show you a typical mistake again. The students say, well, there's nothing up here, so I guess I'll just bring this down, and I've got 5 1/4. But that doesn't make sense. So let's use a monetary value here to give an example. I have $8. I spend 3 1/4. There's no way I can have $5 1/4 left. All right, so we know that's inaccurate. So how do you do these problems? Well, I'll show you real quick. And I'll show you another issue that's going to come up. Well, first of all, you can't take something from nothing. So I have to have something up here. Well, what do? Well, I have to borrow, just like I did in 1st and 2nd grade. Well, 2nd grade, actually. When you had to have help in one of your columns, you borrowed from the column next to it. Well, I don't have anything in I'm going to call this my 4ths column. I don't have anything there, so I'm going to borrow from my 1s column. I'm going to bring over 1 whole. I'm going to take 1 whole and bring it over. Well, I've got to do something to it. I can't just bring a 1 over there. I've got to change this to 4ths. Well, how many 4ths is 1 whole? 4 4ths. So in order to subtract 1/4, I've got to have something over here to subtract it from. So I borrow 1 whole, take it away from my 1's column, and I change it on the way over to 4 4ths. Now I can subtract. 4 minus 1 is 3. Now, since I took 1 whole here, 7 minus 3 is 4. And see, that makes sense. I have $8. I spend 3 1/4. I've got $4 3/4. All right, so let me do one more quick one of those. And I've got 10 minus 7 3/8. Okay? I can't take 3/8 from nothing. So I bring over a whole, But I have to change that whole to whatever I have here. I have eighths here, so that one whole becomes 8/8. Okay, now I can subtract. 8 minus 3 is 5/8. 9 minus 7 is 2. All right, now I'm going to show you one other little issue here that can cause a problem. Say I've got 4 1/3 minus 2 5/8. Okay, this is where the students can really get confused. All right, it doesn't look too bad. The students know that they've got to find a common denominator. So that goes back to everything we just previously talked about today. I've got to find a number that 8 and 3 will both go into. Well, it's going to be 24. If I went up by groups of 8, 3 won't go into 8, 3 won't go into 16, but 3 will go into 24. So I found my number. If I did factor trees on that, or listed all my multiples, 24 is the lowest one. Now, once again, if you can see, you can't do any of this unless you know your time stacks. You can't do multiples without knowing time stacks. So please get those memorized. All right, here we go. I'll change them to 24s. Then I'm going to show you what problem's going to come up. 8 times 3, 5 times 3. 3 times 8, 1 times 8. All right, you look at it and say, whoa, wait a minute. He said that I've got to take 15 from 8, but I can't subtract 15 from 8. If you notice the numerator here, let me get this changed over here, is bigger than that one. So a typical mistake is say the students say, I don't know, I'll just make it work. I'll just say 15 minus 8. Well, you can't do that. It's 8 minus 15. So what do? Well, I've got to have help again. So I come over here to my whole number, and I borrow one whole again. I drop that down to 3, and I'm going to bring that whole number over. But I've got to change it to my denominator. Well, I've got 24ths over here. How many 24ths equal one whole? Well, I'm going to bring over 24 of them. Whoop, you can't see that. All right. I've got 24 24ths, which is one whole. So when I brought that thing over, I brought over one whole, which is 24 24ths. It's always got to be in terms of what your denominator is. Well, I've already got 8 there. So what do? Well, I bring over my 24 24ths and add them to the 8 that I already have. Now I have 32. So now I can subtract. I'm going to have 32 minus 15 is 17 over 24. 3 minus 2 is 1. And you're done. Okay. Now, I'm going to show the students some shortcuts. I'm not going to show you, well, I'll show you real quick. Just one quick one. But I'd rather the students not do this until they can do it the other way. Let's say 3/4 plus 4/5. All right, here's a shortcut, and I don't want the students to do this till they can do it the other way. But this may be something that you can use to help your child later. You can add, multiply these, multiply those. Okay. 15, 16. Add those together and then put it over the product of these. You're going to get 31 over 20, which is 1 11/20. Now, you say, well, that's going to confuse them. Well, it probably will, because they have to understand why this works. If I'm going to work this thing like I did before, here's 20ths, that's my lowest common multiple. 5 times 4, 4 times 4. There's 16. 4 times 5, 3 times 5. 15 plus 16, same answer. That's a shortcut, but unless they understand why it works, it's not worth showing them. You can multiply this times that, put it here. This times that, put it here. Add them, bring it straight out, and then 5 times 4 is 20. You got it. Okay? All right, now that's a lot of material, and I'm sorry, but most of this, I say most of this, is at 5th grade standards. And it is. Some of it we have to teach simply because of math testing. Okay? All right, math has become just as important as past testing, and so I have to expose the students to certain things in order to try to accelerate them on their math testing because of the importance as they enter middle school. But like I say, the majority of this is on, it's at their fifth grade standards. The only thing that is not, and I'm not going to get into this today, the students don't need to know how to multiply or divide fractions and mixed numbers, even though I'm going to show it to them, simply because they will see it on math testing. The rule is real simple. I'll just show you real quick. You just multiply straight across. That's multiplication. 3 times 1, 4 times 2. All right, now division's a little different. Your rules say you never divide, you multiply by the reciprocal of the number that you're dividing by. You change your sign to times, and you just simply flip this one upside down. Then you multiply straight across, 6/4, which is 1 2/4, which is 1 1/2. Now I've got other shortcuts on all these. I'll show the students, but right now all I'm doing with multiplication and division is to make sure they can do it when they see it on math testing. I hope this helped you. I hope you have a great day. Thank you.